Hi everyone. Today we're going to start talking about queues, which is chapter 14 if you're following along in the book. What we're going to talk about basically in this chapter, we're going to talk about queue processing, how queues work. We're going to talk about using queues to solve problems, and then we're going to look at a couple of different queue implementations and sort of compare them. All right, so very similar to stacks and lists or stacks, a queue is a collection whose elements are added in one end and removed from the other. So a stack, we add from one end and we remove from the same end. So it's a LIFO, right? Last in, first out. So a queue is what we call FIFO, first in, first out. So we add things to the back of it. It's like a line at, McDonald's or wherever. So we add things to the back of it and we pull things off the front of it. So in fact, the word queue is exactly that, right? It's a queue. In British English, they call a line a queue. So elements are removed in the same order that they arrive. If you get there first, then you get service first, and that's the way queues work. All right. So any waiting line is a queue. Checking out at the grocery store, cars at a stoplight, assembly line, etc., etc. We've all used to dealing with queues. The operations for these should be pretty straightforward for you. So we have the rear of the queue, which is where we add the elements, and we have what we call the front of the queue, which is where we remove the elements. So you see the things can move along the queue from the rear to the front, just like a line, and that's basically it. You add to the back, you pull off the front. All right, so there's some standard queue operations, just like there were standard stack operations. So there's in queue, which means that we add an element to the rear of the queue. So we're adding something to the queue, we're going to in queue, okay? On the other hand, we have dequeue. Dequeue removes an element from the front of the queue. So if when we call dequeue, we're going to get the first element from the front of the queue. When we call it in queue, we're going to add an element to the rear of the queue. First examines the first element of the queue, which is pretty similar to peak. Why they don't call it peak, I don't know. Go figure. It's pretty much like peak and stacks. It lets us look at the next thing we're fixing to pull off, okay? So it's lets us peek at the thing or look at the first thing in the line. So is empty, again, is just like the stack one. It tells you if this queue is empty or not. Size tells you the number of elements in the queue, and then to string gives you a string representation of the queue, if that makes sense. So these are the standard operations. They're a little different from the stack ones because it's a different data structure. Remember, it's just like a line, right? All these things mean just like a line. So D, Q, sort of in English, we know that means sort of like the opposite of in queue. So it should be pretty clear what these things mean. You do have to memorize these things. Remember what they do. All right. First is just kind of like peak. All right. So queues in the Java API. So again, the Java Collections API is not very consistent about its implementations of collections. So for queues, the API provides a queue interface. There's no queue class. There's a queue interface. And then various classes implement that interface, such as the linked list class. Yeah, that's how it works. So you have a queue interface, and then when you actually instantiate it, it's a linked list. And linked list is going to implement the queue interface. So the queue interface in the Java API is a little weird. There's two versions of the methods that add and remove elements from the queue. And the difference is in how you handle exceptions, or we don't call it exceptions, exceptional situations, meaning errors, sort of. So the add method, and these also don't map onto the sort of the traditional queue methods. They do map on, but they're not named the same. All right. So we have an add method that throws an exception if an element can't be added. And we have an offer method that returns a Boolean indicating whether we added it or we didn't. So this kind of goes back. Some programmers like to use exceptions. Some people like to use Booleans and just detect it in their code. So if you're throwing exceptions, you'll have a try-catch block around your code, and you'll catch the error. And if you are a sort of programmer who likes to use Booleans, you'll say if, q1.offer blah, 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 or if not q1.offer, meaning if it fails, we're going to do something. And so you'll put an if statement around your offer attempt. In the other one, you'll put a try-catch block around your offer attempt. It really doesn't matter. It's up to you. What style do you like the best? Similarly, there's a remove method and a pull method. So the remove method is when we're going to remove an element from the queue, and that will throw an exception. On the other hand, we have the pull method, which does the same thing but returns null if there was nothing to pull off the queue. Okay, so if the queue is empty, you get a null. Again, it's try catch block versus if statement. You're going to check that for the error either way, but would you rather have an exception, or would you rather have just handle it yourself in the code? So the goal is to give you an option of handling these things. Different people like different things. I think personally, especially when you have a lot of different cases, that try catch blocks get a little annoying, but that's just me. Other people like exceptions, and sometimes exceptions are fine. Just get used to it. You'll see code doing both things. All right, so that's the end of this lecture. Next time we're going to talk about some examples of how to use queues. And thanks.